everyone, my name is Wyatt, and today we will be, well, basically phishing. So just before we begin, to keep things legal, use everything that you learned today responsibly, ethically, and legally. Now, most people, when they hear about phishing, this is what they have in mind. You know, typical fraud emails, pretending to be someone that they're not, typos, grammar errors, 1,000 other red flags that we've learned over the years. Now, this is John. John is a senior software engineer at a bank based in Iceland. He lives in Limassol, Cyprus. He works remotely, and his email is jd@9a.is. Now, for the next couple of minutes, I'm going to be John. So we received this email from a company that is called DKIM. It appears to be a provider, cybersecurity service provider working with my bank, and they're inviting me to a cybersecurity awareness training session. That's mandatory. It happens once every year, and they're just asking me to select a date for the training session for a one-on-one session. Nothing more than that. Now, I want to check the domain name just to be sure that we're not falling for a phishing scam. We see here now. You see it's zoomed, but normally it is the typical homepage. So let's click on the button that we have here. What's here? There we go. So we are taken to this page here, which shows a calendar widget behind it, and then it asks us to sign in, because this is an invitation-only page to be able to schedule the meeting. So if we go ahead and we provide the email, and then the password. And by the way, you see here we are at login.microsoft.com. We have a fully interactive browser. Let me just do the multi-factor authentication from my phone. Let's go ahead and say yes, sign in. Now, I see the calendar selection tool. I choose a date. It comes pre-filled with my name, with my email, and then I select no, I haven't done this before, schedule the event. Now, I'm going to receive also an invitation. It's a full, legit Calendly process that is used to schedule meetings. But what just happened right now, here we have an invitation. What just happened right now is that we've been able to steal everything that's needed to get access to this account. We have the username, we have the password, which are shown here, and then we have something even better, which is the authentication tokens. So they got uploaded here. So you see here, we've uploaded to the S3 bucket the username and the password, and then we have the authentication tokens. Now I'm just going to copy them and go to a new browser window. Now if I go to sign in to Microsoft, we see here we're asked to log in. We haven't logged in before. What I'm going to do instead is simply replace the cookies with the ones that we just got from the victim. And then I hit refresh, and we're signed in as John. There we go. We can go to the account, we can look for the takeover, we can go to this thing. Now, this is just a small proof of why multi-factor is no longer the golden nugget and the golden protection. And I haven't invented this kind of technology. It's been out there for a few years now. So let's dive deep into it and get to know how you can launch such an attack So let's get started. First of all, probably the most important part that you have to keep in mind is that you need to select the right domain for the phishing campaign. Now, in my case, I got lucky. I found ETEC-IT, which is exactly what I want, just to pretend to be an IT sales company. But you can go to websites like expireddomains.net, where you can find lots of domains that are either expired, deleted. You can filter based on the top-level domains, so we only go for .com, which is usually more trustworthy and it's more reputable. And then we can check even more filters. One of them, and the important one of them, is basically that BL column you would see, which it stands for backlinks. Now, what are backlinks? They are basically how many times your domain has been mentioned by other domains. The higher the number, the more reputation you have by default. And since we're buying a domain that's expired or deleted, 99% of the databases that keep records of reputation, they don't check if it's been repurchased or expired and purchased again. So you would have the reputation of all the domain that was used for legit purposes. And this is critical, because otherwise, if you buy a new domain, the first 30 days, no matter what you do, you will end up in spam, whatever. That's like guaranteed if they have proper spam controls. Now, one even more interesting place that it's rarely talked about is basically marketplaces and auctions by domain registrars. Here we have Namecheap, a very famous, one of the top domain registrars. You can go into their market and they can give you all the information that you need to make sure that you have a good domain with a good reputation, with many backlinks, with age, and stuff like that. So let's pretend that we've selected ETEC-IT, which is the one that they got. And indeed, I got it from expired domains a few weeks ago. Now, the first thing that we need to check before buying the domain, we have to go and check all blacklists. So we need to make sure that we're not blacklisted by default. So if the domain has been used by somebody for malicious purposes, for spam, for over selling things and sending like too many marketing emails and stuff like that, we can check them with VirusTotal, is it DMARC, Spam House. There are like thousands and thousands of them. Usually, if you don't find your domain in a blacklist in the top 3-4 services, it's not going to be in the blacklist. The second part, which is a little bit lower, is basically the reputation lookup, where we can check databases from McAfee, from Barracuda and other services, and we see this etecit.com by Barracuda at the bottom left. We can see it flagged, categorized as computing technology, which is really good, because this means that we've already gained enough reputation to pass parts of the spam filters. We can see McAfee, it says it's categorized as business with minimal risk. So that's really good. Now, the next step is basically making our domain as legit and as compliant with the industry standards as possible. Even more compliant, I would say, than 80% of the domains out there. First thing, the basics, SSL certificates, HTTPS. Just configure them on whatever you're going to be using behind this domain. The second thing is DMARC and SPF records. So DMARC and SPF records, SPF is basically, without going deep into how it works exactly, it's a way for domains to say that, you know what, if somebody tries sending an email pretending to come from my domain, then I give you basically a specific instruction on how to handle that. Either reject it, quarantine it, send a report back to me using basically the rules set in DMARC. It's a measure to protect against people impersonating your domain, which is also adding a lot of value to the reputation of our domain and spam trackers. Once we've set that up, we can just go and launch our infrastructure. For this case, we just need an EC2 instance or a VM anywhere. Now, personally, I prefer AWS for this type of tasks, just because it gives you some kind of like flexibility later on. If our domain, if the IP of our instance, which is going to be behind the domain, gets blacklisted, with 2 clicks, we can roll a new IP without even disturbing the whole operation, like without any change. Just click, assign an elastic IP, remove it, and that's it. We have a new IP that's not blacklisted. Now, here comes the fun part. There's a tool called Evilginx. Now, probably many of you have heard about it or have seen demos of it. over the years. It's basically a reverse proxy, and what it does and allows us basically to bypass multi-factor and capture everything is that when you're visiting, when the victim is visiting a specific website, which is our phishing website, what we do is from our instance, we send a request to the actual Microsoft login page, we grab the content as it is, we replace a few things inside, basically URLs that are used in API requests, so instead of sending things directly to Microsoft, we send them to us, and then we ship that content to the victim. Now, when the victim enters the user and password, what we do is that, again, we pass it to us, but what's happening is that HTTPS is indeed encrypting the information, but not between the victim and Microsoft, it's encrypting between the victim and us, and then between us and Microsoft. So HTTPS is pretty useless here. The encryption is happening just between us and the other parties. And what's even more important and nicer here is that Microsoft then is going to take those credentials and can say, you know what, we need multi-factor authentication to lock you in. And that probably will happen. What we do is then we grab the content that's being sent, supposedly to the victim, which is the page with either the image or the input or whatever that might be. Grab it as it is, we do minor modifications, and then we send it to the victim as it is. So we're not building the phishing site, we're not building the multi-factor bypass, we're using Microsoft's original content. We show that to the user completes the interaction, we do this one more time towards Microsoft, and then Microsoft issues authentication plugins or authentication cookies. And those, in simple terms, are basically your proof or the proof of anyone to Microsoft that we've already logged in, we've done multi-factor, and we have this specific state, so don't ask us again, at least until those expire. So here's what Evilginx looks like. Now it seems really dark on the screen, but basically it has a naming concept which is called phishlets, which are basically a set of instructions for Evilginx to know what URL to replace with what URL of ours, so how the API calls are happening between between client and Microsoft, and then we replace that, we intercept those and we replace them with ours. And then what cookies to kind of capture, where to find the password, where to find the email. Then, once you have the set of instructions, which is the phishlet, then you have something called lures, which is the actual page or link that you're going to be using for the whole attack. Now, Evilginx, basically Evilginx 3 has been released recently, and it comes with some options that we're going to see later that improve the stealthiness of this attack. However, an important thing, and this does not apply only to Evilginx, but it applies to almost any tool out there that you're going to use for a red team operation, 99% of the time they expose specific attributes that make it easy to detect, and that's done on purpose. Now here in the example of Evilginx, we have one famous example basically that we can collect, which Evilginx basically is setting a header, a specific header called X Evilginx, which is being sent to both Microsoft and the victim. And we can see it in the code in what seems to be a legit code. We can see the home directory being set to .evilginx, and this is where actually Evilginx is going to store all the configuration and files. But then that home there, where is it being called from? It's being called from the second picture, which is get on there. It's replacing the .e with .xe, so now it's becoming the header value instead of the actual directory value. And then the interesting part and the giveaway is that it's being used, the get on there function is being used in request header setting and response header setting, which doesn't make sense. So you have, if you want to be really stealthy, you have to take this open source code, modify it a little bit, try to find whatever identifiable information is there, and rebuild it from source. Now, this is what the page with only Evilginx looks like. It's a full screen, full page of Microsoft. As it is, you have no control over anything that is shown inside of it. And specifically, Microsoft is very tricky. Like they've done some amazing work on the front end to prevent any type of manipulation. So Evilginx has a concept of having your page, your custom page display, Microsoft's login inside, but that doesn't work with Microsoft because it detects this kind of changes. Once you do the first direct, you're left with nothing, basically. It seems fully fishier than just simply this. Now this has HTTPS, but we see the domain is DKIM, which is not good. I mean, like, it's good, but not for us. So we move to the next part. There is a concept called browser in the browser attack. Now, this is basically creating using pure, old, nice HTML, CSS, and JavaScript, what appears to be a browser window, but it's not actually. It's just HTML, CSS, and JavaScript on the actual phishing site. This gives the impression, though, to the user that they are actually providing their credentials to the original site. Now, this was released, I think, 2 years ago or something like that. But what you see on the picture, you see it's really glitchy. I mean, I wouldn't put my credentials there. And the second thing is that, as we said before, Microsoft does a really good job on the front end. So even if you put it, even if you make it nice, it does not work. That's like pure and simple. And researching in the community, asking experts, everyone said it cannot be done. That's the end of the story. So last week I took some time and I created a little bit better version of browser in the browser. We have everything from the HTTPS, of the SSL icon that you click on it and you hover over different things to see the certificates. We have the URL that you can copy and paste to an actual browser and to take you to Microsoft indeed. And it's draggable, expandable, whatever. Now, we still have the main challenge, which is actually making it work with Microsoft, not letting Microsoft just, flush everything away and that's it. So, after trial and error, a lot of trial and error, I came with the idea basically that what if we put another proxy on top of Evilginx? So Evilginx is by itself a reverse proxy, and it's manipulating content on the fly. But what if we put something on top of it that manipulates even further the content that's being served by Evilginx? And I just chose Apache. It seemed like the well-documented option here. And Apache basically ended up serving us for 3 different purposes at the same time. First of all, to make the fraud attack legit, we actually need a landing page. We need a home page. We need to serve all the content. So we can use Apache to serve the static content of our website. That's one. Second thing is basically we can create a blacklist or redirect rules of certain IPs that we know for a fact are used by scanners and abusive scanners, either employed by Microsoft, other services, and stuff like that. So we can use Apache to just filter all of those out, send them to the home page, they see nothing suspicious, and that's it, we're good to go. The third thing is that we can actually, it appears that we can actually replace the HTML content on the fly that's being served to the user, but in a very specific way where we don't touch anything of the original page that Microsoft uses, so we don't raise any red flags, we don't get blocked by the JavaScript code of Microsoft. We just add things on the side without affecting them with unique IDs and stuff like that, and then we use pure old CSS to establish all the fake effect of having the browser actually put Microsoft's login inside of it, interact with it together, and have the effect that we've seen before. And here we have basically, after doing all those steps, we have our landing page, our home page basically, which appears to be something of a cybersecurity company, since it's the theme. And then we have on the right the browser in browser, so basically the advanced version of Evilginx phishing, that the only giveaway would be if the user tries to drag that browser window outside of the page. That wouldn't happen. But other than that, there are no red flags at all. And we're even more cautious about scanners, because if you get blacklisted, then it's a big problem. So what we do is that all the suspicious words that we use, for example, login with Microsoft, we don't use the text login with Microsoft. We obfuscate that and we render it on the fly after a very, very small delay that the human eye cannot notice, but scanners can miss. So this way we construct the text to avoid raising flags. Now, here comes the art of the email. So, I mean, a phishing campaign cannot be successful without having an actual successful email that would reach the inbox. So first of all, we start by crafting a nice looking HTML email Now keep in mind a few things. You cannot use trigger words in this email. If you use things like please, lot, if you use login, if you use Microsoft, if you use, there are lots of lists of words that can trigger spam detection. And the other important thing is that images do not render by default. So all major client provider email clients basically by default, if you haven't interacted with the person before, they will show the image as a broken link. So keep in mind that to build an email that still looks good and legit even without images. Now, in terms of avoiding spam because of the content of the email, there are nice articles. So if you take the Department of Marketing, they're the experts at this. It's their daily job, to dodge spam, to be able to send massive amounts of emails without being detected. So you can find, for example, HubSpot, they publish lists of trigger words that are really nice, that you can run against your email to make sure that you're not going to land in spam. And then you have tools like Mail Genius, which gives you enough free scans for an experimental attack, where you can actually send the actual email that you're going to be sending to them. They will analyze it, and they will tell you different things that you could improve to avoid being affected by spam. Now, remember that we've done, so before we get there, getting ready with the email sending. So the one concept that Evilginx reintroduces as opposed to previous versions is that you can pause your link. You can render basically a redirect instead of the actual phishing page for a specific amount of time. So a good practice is that before sending that email, right before sending, you pause it for 5 minutes. So this way, within those 5 minutes, any scanner, any detection, any mechanism that is going to go check the content, they're going to be seeing the home page or a different page if you're choosing rather than the actual phishing page. And this improves our chances of avoiding spam. The second thing is that, unfortunately for me, I had purchased a private email by Namecheap as the email service provider for this account, and it doesn't allow me to send HTML, proper HTML emails. So I ended up creating a simple Python script that sends the email, creates the email and sends it as HTML. But here comes one extra step, like the extra mile of avoiding detection and making everything look legit. We talk about SPF and DMARC records at the very beginning that we've set in the domain. Here's where they come into play. There is a third thing called DKIM, which is basically an authentication, a signature mechanism where you have your private key, you have a public key that's publicly available, and you sign the content of every email that you're sending out and send the signature together. So the recipient can check that signature and see if it's valid. This adds a tremendous amount of good factors to any email scanner. And you've heard before in previous talks how this kind of headers and checks are kind of the core of detection right now. So sending a test email and then analyzing the headers, there are tools like provided by MX Toolbox, where you can copy and paste the headers of your email and they analyze them. We can see inside those headers that we have, it's pretty zoomed out, that we have SPF, pass, DKIM, pass, DMARC, pass, Microsoft anti-spam, 0 score, other anti-spam features, 0 score. So we have the perfect, basically, the nearly perfect email to bypass the detection and land straight into the inbox of our victim. And with all of this, you have the magic phishing campaign that not only is magic, but it's also fully undetectable. It's fully sneaky. You can try. We tried Source Labs, we tried Aristotle, we tried even Cloudflare. There are like 1,000 services. Even if they scan the original phishing link, it's still nearly impossible for them to detect this if we implement everything that we talked about, including, most importantly, obfuscation of trigger words inside the actual domain. And with that, we conclude our talk for today. I'm not going to go to preventative measures because that's a whole topic on its own, and I'm not the expert with that. But I hope you've had fun, and please feel free to ask any questions and clarifications. And feel free to scan the QR code. I promise it's not phishing or anything. It's just my opinion.
Any questions, guys?